Hey everybody, this is Larry. This is me working on the 15, 16, 17, 18? The 18th day of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join the Discord, and today we're going to talk about course schedule 2. You can see the live portion of me explaining this problem afterwards, but it's going to be a short explanation because this is a textbook solution problem. It's a topological sort. This is actually like as textbook as it gets. So I hope that well, if you don't understand it, it's okay, because that means that you just don't know this algorithm. Because if you do know this algorithm, then you will well, I mean, this is literally how they teach you. But the idea is that you have nodes and you want to sort them in a way such that some nodes have prerequisites, and you want to make sure that all the prerequisites are met for a certain node. So the name of this algorithm is just the topological sort. And there are two general ways, maybe there are more, but two typical ways of doing it. One is using the depth first search, and one is using breadth first search kind of method. And there are a lot of depth first search ways of solving it. So I'm going to, and if you're okay with that, that's fine. I'm going to go over the breadth first search version just to kind of mix it up a little bit. Yeah, and actually let's take a look at the hint. See hint, topological sort. Okay, we knew that. Great tutorial. Oh, this lecture tutorial. Awesome. Oh yeah, so that's what I'm doing here. But the idea is basically you keep track for each node, so I think of, and this is a class thing. So the class is, so the difference between depth first search and a breadth first search version is kind of, I'm going to use English to explain it, because I think, for me, once you're able to describe the problem using a natural English way of explaining it, then it should stick with you easier. And for me, for topological sort, for depth first search first, the question you should ask yourself is, okay, I want to take class A. How can I take class A? Well, I can take class A if I take its prerequisite, which is B, C, and D, or something like that, right? And then you kind of recursively ask that question. Well, I want to take class B. How can I take class B? Well, I can take class B when I finish taking all its prerequisites, and so forth, right? So you kind of do it recursively. And then once you pop off the stack of the recursion stack of asking, well, okay, now I've taken all the prerequisites for class B. Now I can take class B. So then you put it into the answer, and that's how I would think about topological sort. And once you think about it that way, then you don't have to remember like templates or anything, or like, because you're able to express in English how you remember the problem. So breadth first search is similar in that, okay, you have a question of, okay, now I have a catalog of courses. What classes can I take? Well, the classes that I can take are the classes with no current prerequisites, right? So basically that's what I do here. I keep track of, for each class, I keep track of number of prerequisites that class have, and then once I finish doing the pre-processing, I ask myself here, what class have no prerequisites, right? And that's basically what I do here. And then the relaxation is the step is where I would ask. I'll be like, okay, now I'm taking this class, or I just finished taking this class, right? And I put in the answer, and then I ask myself, well, what class relies on this class? Well, for every one of those classes, your prerequisite number goes down. And then after that, you can ask yourself again, well, of all the classes that I just took, or like all the classes that now had this class as a prerequisite, what class can I take now? So that's kind of the English statements that I would use to remember how to solve topological sort. Just kind of every step of the way, ask yourself, I just took these classes, I just took this one class, and that frees me up from possibly another class. And that's pretty much it, both for depth first search and breadth first search. I hope that's a way to help you remember to solve these problems easily. Yeah, and you can watch me go over how to do this problem live right about. Hey everybody, this is Larry. This is the live coding portion of today's Leetcode problem. Let's get right to it. Course schedule 2. Course schedule 2. There are a total of n courses you have to take, labeled 0 to n minus 1. Some courses may have prerequisites. For example, to take course 0, you have to take course 1, which is expressed as a pair, 0, 1. Given the total number of courses and the list of prerequisite pairs, return the ordering of courses you should take to finish all courses. There may be multiple correct orders, you just need to return one of them. If it's impossible to finish all courses, return an empty array. Okay. So yeah, so this sounds like it's just a standard topological sort or topo sort. And there are a couple of ways you can do it. There's the depth first search version and then the breadth first search version. I call it breadth first search, but it's more it's a little bit different. I think I'm going to do it the other way. And I'll go over how I do it with this breadth first search method. And the reason why is because I think everyone generally does it with depth first search. And it's good enough. But I want to expose people to a different technique. Though I maybe need to practice the depth first search version at some point, but that's another story. Cool. Yeah, and the way that I usually set it up is that, okay, so n is equal to number of courses, I think, maybe. Okay, I'm just going to make this easier to write. And then for UV in prerequisites, did I spell that correctly? Hope so. Okay, so which one is U and which one's V? So this one, so the U requires V. Okay. Right? Okay, yeah. So U taking class U requires V. Because sometimes they give it in different order, right? So I just want to make sure. And for this, I just have to keep track of okay, in degree is equal to 0 times n, out degree. I guess I don't really need it, but still gonna keep track of it. And then just the graph in general, which is graph is equal to, let's just do collections dot default tick of a list. So this basically is just a map, like in C++, it just looked like this or something like that. Or I guess this is a vector, but something like that. So that's basically what I'm doing. Cool. And then now in the so that means that what we want is that taking U requires taking V, right? So we want to have an edge from V to U, so that yeah, that's the way that I would set it up. So in degree of U is increment by 1. Out degree of V is increment by 1. I think that's, yeah. And then we just update the graph of V append U. Okay. And these are more like edges, I guess. Okay, let's just call it edges. Oops. Okay. So then now we can just, use a queue. It's more like a queue-based solution. It probably isn't technically breadth first search, depending on how you want to define it. But then now we want to relax all the nodes with 0 in degree, right? What does it mean to have 0 in degree? That means that there's no prerequisite for that class, right? That means that if you have 0 in degree, that means that there's 0 classes pointing at you as a prerequisite. So that means that you should be able to execute it. Yeah, I think some notation may do it the other way, actually, now that I think about it. But I think as long as you're consistent with how you think about the problem, it should be okay. So yeah, so let's do for, let's just say I in range of n, if in degree of I is equal to 0, q dot append I. Okay, so then now we do relaxing with putting things on the queue. So then now the current node is equal to q sub 0, and then we pop left. And actually this should be collections.q, or deck to be more precise, because in Python decks have a pop left. Okay, so now what does it mean to add this to the node, right? Well, that means that we can, let's have an answer array. That means that we can take the class now, because that means that this all the prerequisite has been done. So then we append node, and then now what does that mean? That means that for every node that did I get the edges right? Yeah, so now that means that for every node that is connected to this edge, you can take that class again. Then, for example, if I took Physics 101, and Physics 101 is a prerequisite for Physics 102, that means now there are one fewer prerequisites for Physics 102. And then if that new degree is 0, then we can take it off. So now for what's the opposite of prereq? I don't know. And classes are part of the keyword. So let's just say for v in edges of node. So these are classes that node is a prerequisite for. V is a class that node is a prereq for, just to be a little bit clear. Then we want to set the in degree to just subtract 1 because we satisfy one of its prerequisites. And then now we can check if in degree of v is equal to 0. That means now all the prerequisites are done. Then we can put it in the queue. Push no. I think it's a pen. Oops. And that's pretty much it. Oops. What happened here? Now we check whether if length of answer is equal to n, then we just return the answer. That means that we took every class, right? Otherwise, we return -1 or whatever it is. What is the return an empty array? Okay, yeah. So that's I think that should be good. So let's run them for the test cases. Okay. Ooh, no, so not so good. How did I even get 0, 0? That's a little odd. Oh, that's because I pushed node instead. Okay. Whew. So just a little bit typo. Thanks for bearing with me. This part looks good. Is this good enough? 1 has 0 as a prerequisite and 2 of 0. Just checking the answers real quick because there are multiple answers. Actually, I think it tells you that. Okay, so it looks like it's good. We could actually try some cases with like empty arrays and stuff like that, but I think we're okay. So let's run this real quick. And yeah, it looks okay. Yeah, I mean it could be any number. So let's submit it. And yes, cool. So I hope that I showed you a different way of solving it, or at least one that maybe you're not as practiced on. They're roughly the same. The thing that gives you a little bit more different is that conceptually, if you do things in a way, it allows you to have different sort of ordering depending on how you want to do tiebreakers. But that's doesn't come up that often, so maybe that's okay. But if you want to upsolve it, try using both. That's what I have for today's problem. Hit the like button, hit the subscribe button, join the Discord, and I will see y'all tomorrow. Bye bye.